In the previous video, talk about the relationship between the distribution function and the histogram. Now, we will talk about mm, the relationship between the population, which is um, which is let's say denoted or represented by a random variable, and the relationship between the sample data. So, in fact, the whole story is we have a population like the students, right? The students in Özyeğin University, and we are interested in their, let's say, height. It's almost impossible, or even if it is, it's very expensive to measure the heights of all of them. I want to find the average height of the students in Özyeğin. So what I do is I take a sample, right? A sample which is representative of the remaining students. Let's say this class, MAT 216. The students here is a representative of this school. Okay, so there are lots of students here. Okay, and the thing is, sorry, um, sorry for bad drawing. So there are lots of guys here. So I'm choosing a sample, and the thing is that, well, the population has a mean which is denoted by mu. So that's the average height of the Özyeğin students, and the variance sigma squared. That's the variance of, again, the height of the students in Özyeğin University. This is the average height of the students in Özyeğin University as well. But it's almost impossible, even if it is possible, it's very expensive to calculate real mu or real sigma squared. Or, in fact, let's add one more, proportion, which let's denote it by pi, capital pi, okay, capital pi. So it's almost impossible to find, for example, the average height or the variance of the height or the proportion of people in Özyeğin who likes Cafe Nero. Okay, so what we do is we take a sample, right? We take a sample and calculate x bar. So this is bar, x bar. Well, x bar is a representative of the mean, and we calculate S square. S square is a representative of the sigma square. And we calculate P, which is the representative of the proportion. For example, if we look at the heights of the students in this class, and if it turns out that x bar is equal to, I'm just making up, 172 centimeters, then we can say that, well, we can say two things. First, if you want to use a number, if you want to, if you have to use a number instead of mu, well, that's the thing that you can use. You can use for mu, right? This is the first thing. The second thing, if it is not exactly the number, but if you are being asked for, if you are being asked for what are the plausible, what are the acceptable values of mu, then you can say that, well, the real mu is somewhere very close to 172 centimeters, right? Similarly, if s squared turns out to be, for example, 15 centimeters, you can say that, well, the real sigma square is somewhere close to 15 centimeters. Or if you ask this class and if it turns out that, well, p is equal to 0.955, 55% of people likes Cafe Nero, then the real proportion in the school, um, it can be what? It can be very close to 55%. Okay. Now, right, we will use X bar, okay, to infer information about the real parameter mu, but how? Okay, let's see we will how. Now, um, so, okay, let's stop here and let's continue with the next video.